So in this question, we're shown figure 2, and that's a sketch of the curve C with the equation y is equal to f of x, where f of x is equal to 4 lots of x squared minus 2 multiplied by e to the power of negative 2x. And what we're asked to do here, we're asked to show that f dash x is equal to 8 lots of 2 plus x minus x squared multiplied by e to the power of negative 2x. So essentially what we're being asked to do is we're to take f of x and differentiate it to reach the required answer. So how are we going to do this? So we know we have one function and we multiply it by another function. So we know we can differentiate this using the product rule. So I've already written the product rule out here. So if we have one function g of x and one function h of x, then the derivative of the overall function f of x is going to equal the derivative of g multiplied by h of x, then g of x multiplied by the derivative of h. So now for us, what we can do, we can now name our functions g and h to make things slightly easier. So if we let g of x be equal to 4 lots of x squared minus 2, and then if we let h of x be equal to e negative 2x, then we now face some differentiation, which looks slightly easier than tackling this as a whole. So then we'll have the g dash x, so the derivative of g. So then what we do is we'll multiply out the brackets. So we'll have 4x squared. What does that differentiate to? Well, it differentiates to 8x. And then we have the constant negative 8, that differentiates to nothing. So the derivative of g of x is going to equal to 8 of x. And then likewise, for h of x, we'll have the derivative of h of x is going to be equal to, so we know for logarithms, we multiply it by the derivative of the power. So the derivative of negative 2x is going to be negative 2, and then the rest remains the same, so that's e to the power of negative 2x. So therefore, we can say that our function f of x, the derivative of it, is going to equal 8x multiplied by e negative 2x, and then to that we add 4 lots of x squared minus 2, and we multiply that by minus 2e negative 2x. So then simplifying this ever so slightly, this is going to be equal to, so we can keep this part on the left the same, and then this is going to turn into negative 8 because we have 4 multiplied by negative 2, and then we're going to have our e negative 2x, and then our brackets stay there, x squared minus 2. So what we can now do is we can take out a common factor of 8, and we can take out a common factor of e to the power of negative 2x. So therefore, this is still f of x, and we're going to take out our common factor of 8, and then we're going to have that is going to be, to get to this first term, we're going to have that you multiply it by x, then for the second term, you're going to multiply by negative x squared, and then positive 2, and then we have our other common factor here, which is e to the power of negative 2x. So recalling the question, we're wanting to show that f dash x is equal to this, so we have our 8 here, so that's good. We have our e negative 2x, and then inside the brackets we have 2, we have negative x squared, and we have x. So therefore, we can just tidy this up just into the exact form that they wanted it. So we keep our 8, and then we're going to have, like they say in the question, 2 plus x, then we minus x squared, then we multiply e by the power of negative 2x, and we write as required, as this is what the question asks us to show. So therefore, we've completed this question. It was worth 3 marks, and we received our first mark for attempting to use the product rule and then starting to differentiate. So we get 1 mark here for attempting to use the product rule, and we then get our second mark for differentiating, and we then receive our third mark for having the answer which the question asked us to show. So here in part B of the question, we're asked to find, in the simplest form, the exact coordinates of the stationary point of the curve C. So the first thing that springs to mind when we hear stationary point is that we want to set the derivative equal to 0 and then solve for x, and these will be the values of our stationary point. So I've copied down our work from part A. So this was the derivative of f. So what we're going to do is we're going to set this equal to 0. So therefore we'll have that 8 multiplied by 2 plus x minus x squared multiplied by e negative 2x is going to be equal to 0. So now we see if we divide both sides by 8, this 8 will cancel out, and then if we divide both sides by e to the power of negative 2x, it will be cancelled out here as well. So this leaves us with a quadratic. So we'll have 2 plus x minus x squared, and that's going to be equal to 0. And I'll just note down, we went from here to here by dividing by 8, and we also divided by e to negative 2x, and that was on both sides. So then the next step for us, we should probably multiply both sides of our equation by negative 1. And why do we do this? Well, this will give us an easier quadratic to solve, as the x squared term will be positive. So this means we'll have x squared minus x minus 2, and that's going to be equal to 0. So now I want to solve this. So we want a number that multiplies to negative 2 and adds to negative 1. So what numbers fit this? So if we have negative 2 and multiply it by positive 1, that gives negative 2. And negative 2 plus 1 is equal to minus 1 also. So this is good. So this means our factors are going to be negative 2 and 1. So we have therefore that x minus 2 and x plus 1 equals 0. So therefore we have that x is equal to 2 and x is equal to negative 1. So we've found our x coordinates, and we now want to find the y coordinates. So we know that when x is equal to 2, y is equal to f of 2, which is going to be equal to 4 lots of 2 squared. Then we subtract 2, and then we multiply this by e to the power of negative 2 multiplied by 2. And then simplifying this a little bit further, we'll have that this is going to be 4 lots of 2 multiplied by e negative 4, which is going to be equal to 8e negative 4. And we note in the question that we're asked to give the exact coordinates, so we're not going to put this into the calculator, we're just going to leave this like this. So that's our y coordinate. And then for x equals to minus 1, we'll do the same. Y is going to equal f of minus 1, which is going to be equal to 4 lots of minus 1 squared. Then we subtract 2 and multiply that by e negative 2 to negative 1. Well, this is going to be equal to 4 lots of negative 1, which is negative 4e to the power of 2. And that's equal to y also. So therefore, our coordinates are... So our first one was, the x coordinate was 2 and the y coordinate was 8e negative 4. And then secondly, we had that x was equal to negative 1, and the y coordinate which went with this was negative 4e to the power of 2. And therefore, we've completed this question and worked out the coordinates. Looking back at the question, this was worth 3 marks. We received our first mark for getting our 2 x values, so that was 2 and negative 1. We then received our second mark for substituting in one value of x to find a value for y. So we do that for the first time here, and then we receive our third and final mark for concluding with the correct answer and saying the coordinates are 2, 8e to negative 4, and negative 1, negative 4e squared. And they are the coordinates of our stationary points. So here in part C of the question, we're given some further information. We're given 2 new functions. We're told that g of x is going to be equal to 2 lots of f of x, and that's for x in the reals. And we know that h of x is going to be 2 lots of f of x minus 3, and that's going to be for x greater than or equal to 0. And in part C1, we're asked to find the range of g. So we have to think, what is the function g of x going to be? So it's going to be 2 lots of f of x. We know f of x here. So this means that g of x is going to be 8 lots of x squared minus 2 multiplied by e to the negative 2x. Why 8? 8 comes from 2 multiplied by 4. So we need to have a think about what the range is, and the range is going to be the output of our function. So this is the values that we get on the y-axis. And we know a couple of points here. So we know this point here and this point here. That's our two turning points. So we need to have a think now, what values is our y-axis going to take? So we can see here, this is the minimum turning point, and this was of f in the graph. So we know that if the coordinates of f of x are a, b, then the coordinates of g of x are going to be a, 2b. And that's because g of x is 2 lots of f of x. So therefore, we can use this to help us. So we can see here on the graph that the lower limit of the range of g of x is going to occur here, because this is the low point of the function. And what is that? We know that's the minimum stationary point. We had two stationary points, and they had x coordinates 2 and -1. So we know this is going to be the one with the x coordinate -1. So therefore, we know that the lower limit of the range is going to be 2 lots of the y coordinate. So therefore, we'll say that the lower limit of range, that is going to be 2 lots of -4 e squared. And what's that going to be? That is going to be -8 e squared. And then we need to have a think, what is the maximum, so the upper limit of the range going to be? Well, we can see it's not going to be this turning point here, and we can see that this is going to go on infinitely. So therefore, we can say the upper limit of the range is going to be infinity. So therefore, we can say that the range is as follows. It's going to be from the closed endpoint, -8 e squared all the way to infinity. Then we look to the next part of the question. So we have question C part 2, and we have that h of x is going to be equal to 2 of f of x minus 3. So that's going to be equal to the same as g of x, but we subtract 3, so that's going to be 8 x squared minus 2, and then e -2x minus 3. So we first need to think, right, well, is there any further information we're told? Well, yes. So in the question we were told that this is only valid for x greater than 0. So therefore, we'll write that this is for x greater than or equal to 0. So this time we're only going to be dealing with this part of our graph here. So everything to the right-hand side of the axis. And we see, what is the lowest part of the y-axis going to be? It is going to be when we have the y-intercept, so when x is equal to 0. So we must first state that the lower limit of the range will be at x equals 0. So therefore, we'll have that h of 0 is going to be 8 lots of -2 multiplied by e -2 times 0 minus 3. And we put this into our calculator. And what is this going to be? So we're going to have -16 minus 3, and that's going to be -19. So then we can now think about the upper limit. So what's it going to be? So we're looking at everything on the right-hand side of the y-axis. So what's the highest point on the x-axis? So what's the highest point on this y-axis? Well, it's going to be our maximum turning point. So then we can say that the upper bound will be our maximum turning point. And we need to think, why is this? And this is since this is only valid for x greater than or equal to 0. And we recall from part B, this max turning point had y value of 8e -4. But this time, we know that our function has been doubled and shifted by -3. So therefore, for the h of x function, this point will be 2 lots of 8e -4, and then we subtract 3. So what's this going to be equal to? This is going to be equal to 16e -4, take away 3. So therefore, we can conclude that the range is going to be -19 as the lower limit, and the upper limit is going to be 16e to the power -4, take away 3. and therefore we've completed this question. Question C was worth 3 marks, and we received 1 mark for stating the range in part 1. So that's here we got that. Then in the second part of the question, we got 1 mark for identifying either the lower limit or the upper limit of the range. So we'll put our first mark in here when we identified the lower limit of it, and then we receive the 3rd mark for this question for concluding with the correct answer.